All right, so for this problem, we're looking at given two planes in R3, find the line of intersection. I'm going to show you a way to do this where we're not going to have to use any vector properties or have to think about these planes geometrically. We're just going to solve some equations. So the first step of this is to solve P and Q for X. So for P, we have 3x plus 2y plus z equals 3. So we're going to get all the x's alone by moving the y and the z over to the left side, or the right side rather. 3x equals 3 minus 2y minus z. Okay, and dividing by 3 here. X equals 1 minus 2 over 3y minus 1 over 3z. Okay, so we're going to do this for Q now. Q equals 2x minus y minus z equals 4. Again, solving for x. Two x equals 4 plus y plus z. And now dividing by 2. X equals 2 plus 1 over 2y plus 1 over 2z. So for step 2, we're going to set these equations equal to each other, and we're going to solve for another variable. Here I'm going to do y. So 1 minus 2/3 y minus 1/3 z. Equals 2 plus 1/2 y plus 1/2 z. And here we're going to try to isolate the y on the left-hand side. So I'm going to take it off the right-hand side. And then we're going to move everything else that's not a y over to the right-hand side. So the 1 cancels. Minus 2/3 y minus 1/2 y. So this is like 2/3 plus 1/2. And you can try that out for your own, but we're going to get 7 over 6y. The z cancels. Equals 1. 1/2 z plus 1/3 z is 5 over 6z. Okay, and now we need to, and this is actually a minus. Now we need to cancel out the minus 7/6 by multiplying it by minus 6 over 7. Both sides. Y equals minus 6 over 7. And now we have 5/6 times minus 6 over 7. The 6 cancels. Minus 5 over 7 z. Step 3. So we have y in terms of z. We're going to plug this back into one of our equations for x. Equation for x from step 1. Either one's fine. And that's going to give us x just in terms of z. So here we have it in terms of y and z. We have our equation for y. So plugging this in, we get 1 minus 1 over 3z minus 2 over 3, and here's where we plug in y, is minus 6 over 7 minus 5 over 7 times z. So distributing the negative 2 over 3, this becomes 2 over 7, and this 3 cancels out, so it's actually going to be 4 over 7 plus 2/3 times 5/7 plus 10 over 21 z. And then we still have our 1 and our minus 1/3. I'm just going to write this out, plus 7 over 7. And minus 1/3 is minus 7 over 21 z. So here we have 11 over 7 plus 3 over 21, which is 1 over 7 z. So now we have x and y just in terms of z. Writing everything out, our line of intersection follows the equations x equals 11 over 7 plus 1 over 7z. Y equals minus 6 over 7 minus 5 over 7z. And z equals c. So to get this in parametric form, all you have to do, I'm going to set z equal to t. We're going to have x of t. It's the exact same thing. We're just changing z to t. All right. So this is the equation for the line broken into its components in each dimension, and all in terms of the same parameter t. So this is parametric form. If you check, when you're doing your problem, make sure you check what form you need to put your answer in. And if you need to have it in another form, say symmetric form or vector form, you're going to have to convert this answer. But that's pretty easily done. I'll have another video on how to do that.